Hello all, welcome to Brilliant Coaching Classes. I am Nilima Patil. In this video, we are going to solve practice set 4.1. First question, figure of triangle is given. This is triangle LMN. And question is, in triangle LMN, dash is an altitude and dash is a median. Write the names of appropriate segments. Now in this triangle, which is an altitude? Now what is altitude? Altitude is a perpendicular drawn from a vertex to its opposite side. So here LX is a perpendicular drawn on the opposite side MN. Therefore LX is an altitude. So here we will write LX is an altitude and dash is a median. So here median is LY because Y is a midpoint of this segment MN. So LY is a median. LY is a median. So this is question number 1. Question number 2. Draw an acute angled triangle PQR. Draw all its altitudes. Name the point of concurrence as O. First, we'll draw an acute angled triangle. So this is the acute angled triangle. Each angle of this triangle is less than 90 degree. Now we'll name this triangle as PQR. Now draw all its altitudes. So to draw the altitude, first from point P, from this vertex P on the opposite side QR, will draw the altitude using the set square. Even you can draw the altitude using compass, but we'll use set square. So this is the first altitude from the vertex P. We'll name this as PM. So this is altitude PM. Next, from this vertex R, we'll draw the altitude on the opposite side PQ. So we'll keep this set square like this. So one edge of the set square is touching to this side PQ and the another edge is touching here at the vertex R. And this is the another altitude. This is perpendicular. We'll name this point as N. So Rn is the another altitude. Next, we'll draw the third altitude from this point Q, from this vertex Q on the opposite side PR. So keep the set square like this. One edge of the set square is touching to side PR and the other edge is touching to this vertex Q. Now we'll name this point as L. Here it is 90 degree. So segment QL is the altitude on side PR. So here we have drawn all the three altitudes of this triangle: segment QL, segment RN and segment PM are the three altitudes. Now name the point of concurrence as O. So the point of concurrence of these three altitudes is here, and we'll name this point as O. So this is point O. Question number 3. Draw an obtuse angled triangle STV. Draw its medians and show the centroid. So first we'll draw one obtuse angled triangle. So this is the first side of the triangle. Then we'll draw this side, second side, and now we'll join here. So the triangle is completed here. We'll name this triangle as STV. So here S, here T, and here V. So this is triangle STV, which is obtuse angle at vertex S. So this is the angle which is greater than 90 degree. Now draw its medians. So to draw the medians, first we'll draw the bisectors of all these three sides of the triangle. After bisecting these sides, we'll get the midpoint, and that midpoint will join with the opposite vertex and we'll get the median. So using set square, we'll draw the bisectors of all the three sides. So first, for this side ST, we'll draw the bisector. So taking more than half distance of this side. See, I have taken more than half distance, and we'll draw arcs on both the sides of this segment ST. Now from point S, we'll draw the arc intersecting to the previous arc. Now join these 2 points, and this is the bisector of segment ST. So here we got midpoint of this ST. We'll name this point as P. So P is a midpoint of segment ST. It is the side of this triangle STV. Now we'll join this point P with the opposite vertex V, and we will get the first median. So VP is the first median. Now we'll draw the bisector for this side VS. So put the metal point here on S, taking more than half distance. We'll draw the arcs on both the sides from this point S. Then from point V, taking the same distance, we'll draw the arc. Now this arc is not intersecting to the previous arc, so once again we'll keep this point, middle point on vertex S, and draw the arc which will cut this arc. Now we'll join these arcs and this line will be the bisector of segment SV. So this line is bisector of this SV, and therefore this point is a midpoint of side SV. We'll name this point as Q. And now this midpoint will be joined with this opposite vertex T, and we'll get the second median of this triangle STV. So this is the second median. TQ is the median. Now third side VT. For this side VT, we'll draw the bisector. Take the compass. Take more than half distance of this segment VT. Draw the arcs on both sides of this segment VT. Now from point T, I drew these two arcs. Now from point V, we'll draw the arcs which are intersecting with these arcs which are previously drawn. Now again here this is not intersecting, so again we'll keep the compass metal point on T and continue with this arc. Now these are intersecting to each other. These arcs are intersecting here and these two are intersecting here. Now we'll join these arcs and we'll get the bisector of the third side VT. So this is the bisector of side VT. It means this is the midpoint of VT. We'll name that point as R. So R is a midpoint of VT. Now join this R with vertex S, because this is the vertex opposite to this side VT, and we'll get the third median. So this is the third median. So here we got all the three medians. First is SR, next is TQ, and third is VP. So these are the three medians and they are intersecting each other here. So this is the point of concurrence of all the three medians, and this is the centroid. Centroid is always denoted by the letter G. So this is the centroid. Here question, draw its medians and show the centroid. So this is the centroid, and this is our figure for question number 3. Question number 4. Draw an obtuse angled triangle LMN. Draw its altitudes and denote the orthocenter by O. So first we'll draw an obtuse angled triangle. This is second side of the triangle, then the third side. Name this triangle as LMN. So here we'll name L, this is M, this vertex is M, and this is N. So this is triangle LMN. where angle M measures more than 90 degree. The measurement of angle M is more than 90 degree. So here it is obtuse angle, and therefore this triangle LMN is an obtuse angled triangle. Now draw its altitudes. First we'll draw the altitude from this vertex M to this side, opposite side LN. So using set square we'll draw the altitude. So first match this edge of this set square with side LN, and the other edge should be touching to the vertex M. So this is the altitude. We'll name this point as P. So MP is an altitude on side LN. Next, now from this vertex L we'll draw another altitude, and which will be on this side NM. But this altitude will be in the exterior of this triangle, in the exterior part outside of this triangle. So we should extend this MN this side. So extend side MN. Extend side MN. And now we'll draw the altitude from vertex L. So keep the set square like this. This edge is touching to this side, and the other edge of the set square is touching to this vertex L. So this is the second altitude. Name here Q. This point is named as Q. Now we'll extend this altitude down as well as this altitude also. MP and LQ altitudes are extended below so that they will touch each other, and we'll get the orthocenter. The point of concurrence of all the three altitudes is orthocenter. And we know that the orthocenter of the obtuse angled triangle is in the exterior of the triangle, and it is behind the obtuse angle. The orthocenter is behind the obtuse angle. M is an obtuse angle. So here we got these two altitudes are touching in this point. Now we'll draw the third altitude from this point N. The third altitude we'll draw from this point N, from the vertex N. For that we will extend this side LM, because again this altitude will be outside the triangle. So extend this side, extend LM, and now from this vertex N we'll draw the altitude using the set square. So keep the set square like this. One edge is touching to the side LM, and the other edge of the set square is touching to this vertex N. And now draw the altitude. So this is the third altitude. We'll name this point as R. So NR is the third altitude. First altitude was MP from the vertex M of this obtuse angle triangle LMN. Second altitude we drew, it was from this vertex L, so it is LQ, and now the third altitude is NR. Now again we'll extend this NR such that all the three altitudes will be concurrent. They will meet in one point, and that point is orthocenter. So extend this altitude NR. So all the three altitudes are concurrent here in this point. So we will name this point as O. This is the orthocenter where all the three altitudes of this obtuse angled triangle are concurrent. So this is the orthocenter and we denoted it by O. Next, question number 5. Draw a right angled triangle XYZ, draw its medians and show their point of concurrence by G. So first we'll draw a right angled triangle. So here this is the first side of the triangle. Next we'll use the protractor to find the measurement of the angle, 90 degree. So here it is 90 degree. Now we'll draw the second side. So this is the second side of the triangle, which is right angled here. This angle is 90 degree. And now we join these 2 points. And here the right angle triangle is completed. We'll name this triangle as XYZ. So here X, this point, this vertex is Y and this vertex is Z. So this is a right angle triangle XYZ. Now draw its medians. Now to draw the medians, first we'll find out its midpoints of all the three sides. So we'll bisect this YZ and we'll get the midpoint. Again we'll bisect this side XY, we'll get the midpoint of that side. Then we'll find out the midpoint of XZ also by drawing the bisectors of all these three sides. For that, take more than half distance in this compass and draw the arcs upside of this side as well as down, up and down both sides. Now put the metal point here on Y and draw another arc which will cut the previous arc. And now join these points and we'll get the bisector. We'll get the bisector of side YZ. It means this is the midpoint of this side YZ. Name this point as P. So here P is the midpoint of YZ. Now this P will be joined with the opposite vertex X and we'll get the median. So XP will be the median. So this is XP, the first median we got for this triangle. Now we'll bisect side XY. So again take more than half distance, draw the arcs. So I have taken this much distance, I'll reduce it little. So I have taken this much distance and we'll draw the arcs on both the sides of this XY. You can increase the distance, you can take more distance also, you can take the distance equal to this side also XY and draw the arcs. So I'll draw one arc here, another arc will be this side. Now from this vertex X again we'll draw the arcs. And now we'll join these points and we'll get the bisector of this XY. It means we'll get the midpoint also. Here we got the midpoint of side XY. Name this point as Q. So Q is the midpoint of side XY. Now we'll join this point Q with the opposite vertex Z and we'll get the second median of this right angle triangle XYZ. So this is the median. We got two medians, median XP and this ZQ is also the median. Now we'll bisect this third side XZ and we will get the midpoint of this side and then we'll draw the median also. So bisect this side XZ to get the midpoint. So I have taken this much distance, more than half distance of this segment XZ and we'll draw the arcs on both the sides. Now keep the middle point on X and draw the arc. Now we'll draw the arc here. Okay. Now we'll join those arcs. So this point and this point will be joined. These 2 points will be joined and we'll get the midpoint. This line is intersecting side XZ at this point and we'll get the midpoint of XZ. Now we'll join this with Y. First name this point as R. So this point is R. Now we'll join this point R with the vertex Y, the opposite vertex Y. So here is the third median. We'll get the third median YR. So YR is the third median. Now see, we got all the 3 medians. First median is XP, another median is ZQ and third median is YR. And all the 3 medians are concurrent here in this point. And this point is called centroid. and we denote this point as G. Here it is given, show their point of concurrence by G. So we will name this point as G, and that is the centroid. Centroid is a point of concurrence of all the medians. Question number 6. Draw an isosceles triangle. Draw all of its medians and altitudes. Write your observation about their points of concurrence. So first we'll draw an isosceles triangle. The triangle whose two sides are equal. So first we'll draw the base. We'll take the base 7 centimeter. 7 centimeter, and then we'll take those two equal sides 8 centimeter. So two sides will take 8 centimeter each. So we'll make two arcs which are intersecting, and we'll get the isosceles triangle by joining these 2 points, and this side also will join. Draw the segment. Now the triangle is completed, and this is isosceles triangle. Name this as A, B, C. So point A is the first vertex, then B, and then C. BC is the base of this isosceles triangle. Side AB is equal to side AC. These two sides are equal. So this is isosceles triangle. Now draw all its medians. Now to draw the medians, first we will bisect all these 3 sides, so that we will get the midpoints of these 3 sides. So first take more than half distance and draw the arcs on both sides of this segment BC. From point B, again draw the arcs. Now join these arcs. And after joining this, we will get the midpoint of side BC. So this is, say, point P. So point P is a midpoint of BC. Now if we join this point P with the vertex A, then we'll get the median. So let us join this and we'll get the median PA or AP. So this is the median. AP is the median. Now we'll bisect this side AC and we'll get the midpoint. Again I have taken more than half distance, and we'll draw the arcs on both the sides of segment AC. Now here again this side. Join this and we'll get the midpoint of side AC. So this is the midpoint of side AC. Name this point as Q. Now join this point Q, the midpoint Q, with the opposite vertex B, and we'll get the another median. So join these 2 points and we got the median BQ. So this is the median BQ. First we got median AP. Now we'll bisect this third side AB to get the midpoint of AB. Again, taking more than half distance, we'll draw arcs on both the sides of AB. Now keep the metal point on B, taking the same distance, draw the arcs. Now join these points where the arcs are intersecting and we'll get the midpoint of side AB. So this is the midpoint of side AB. We'll name this point as R. So R is a midpoint of side AB. Now join this R with the opposite vertex C and we'll get the third median of this triangle. So this is the median. Now we got all the 3 medians. First is segment AP is the median, then CR is another median and BQ is the third median. All the 3 medians are concurrent here in this point. So it is centroid. This point is the centroid and we name this point as G. So this is the centroid. The point of concurrence of all the medians is here and we denoted it as G. Now we'll draw all the altitudes of this isosceles triangle. Using set square also you can draw the altitude or you can use compass also, but here we'll use set square only. Now to draw the altitude from this vertex A on the opposite side BC, we keep the set square like this. One edge is touching to side BC and the other edge is touching to this vertex A. And we draw the segment. Now here already this median is there and that is a altitude also. So here the median and the altitude both are same. So segment AP is the median as well as altitude. Now we'll draw the altitude from this vertex C on side AB. So keep the set square like this. This edge will touch to side AB and the other edge will touch to this vertex C. And draw the altitude. So here we'll name as L. So CL is the altitude. Now from this vertex B on AC we'll draw the altitude. So keep the set square like this. One edge of the set square is touching to side AC and the other edge is touching to this vertex B. And draw the altitude. So this is the altitude. Here name as M. This point is M. This is perpendicular here. So BM is the third altitude. Now we got all the 3 altitudes. AP is an altitude, BM is an altitude and CL is also an altitude, and all these 3 altitudes are concurrent here in this point and we will name this point as O. This is a orthocenter. So we got the centroid as well as orthocenter on the same segment AP. So this is our observation. Here the question, write your observation about their points of concurrence. So the point of concurrence of all the medians and all the altitudes is on the same segment, which is perpendicular on the base of this isosceles triangle. Question number 7, fill in the blanks. Triangle ABC is given. G is the centroid. It means AP, CR and BQ are the medians. And you know the property of centroid. The centroid divides the each median in the ratio 2:1. So here fill in the blanks. Point G is the centroid of triangle ABC. First, if length RG is equal to 2.5, so this is RG which is given 2.5, and find the length GC. So length GC is equal to blank space is given, so we'll find out how much is the length GC using the property of centroid. We know that the centroid divides each median in 2:1 ratio. So using the property of centroid. So for this median CR, it will be CG by RG. CG or GC you can write RG is equal to 2/1. The ratio is 2:1, so we can write 2/1. Now we have to find this CG. So CG by, now RG is given 2.5, so RG 2.5 is equal to 2/1. If you cross multiply, we will get CG into 1 is CG is equal to 2.5 into 2. 2.5 into 2. So this CG, it means GC only. We get 2.5 into 2 is 5.0. So GC is 5. Length GC is 5. We can write here. Next, if length BG is equal to 6. Now see here, this is BG. Then length BQ is how much? So we have to find complete BQ. But for that, first we'll find out GQ using the same property. So we write here BG by GQ is equal to 2/1, the property of centroid. The centroid divides the median in 2:1 ratio. Now BG is given 6. 6 by GQ is equal to 2/1. Now to find this GQ, we'll divide this to here. So GQ is equal to 6/2. Therefore we'll get GQ is equal to 3. Now GQ is equal to 3. Now using this GQ and BG, BG is 6, GQ is 3, we'll get BQ. So we can write BQ is equal to, BG is 6 and GQ is 3. So that is equal to 9. So BQ is equal to 9. So we'll write here BQ is equal to 9. Next, third, if length AP is equal to 6, then length AG is how much and length GP is also how much? Now see, AP is given 6. So this AP. Now we know that AP is equal to AG plus GP, and AG is to GP is equal to 2:1. Using the centroid property, we can write AG by GP is equal to 2/1, and therefore we'll get AG is equal to 2x and GP is equal to 1x. The common multiple of this is x. We have taken it as x. Now AP is equal to AG plus GP, and that is 2x plus x. So it is 3x, but we know that AP is equal to 6, and so we can find out x is equal to 6 divided by 3, and we will get x is equal to 2. Now using this x is equal to 2, we can find out AG. AG is equal to 2x. So length AG is equal to 2x, that is 2 into x value 2. So it is 4. Length AG is 4. So we will write here AG is 4. And length GP. Length GP is equal to x. And what is x? X is 2. So length GP is 2. So write here 2. And this is our answer. If length RG is equal to 2.5, then length GC is 5. Length BG is equal to 6, then length BQ is 9. Length AP is 6, then length AG is 4, and length GP is 2. So here we have completed our practice set 4.1. Thank you.